Question 55 says determine the area under the region bounded by y equals 2x squared plus 10 and y equals 4x plus 16. Looking at the second equation, you know it's a line graph while this is a curve. So we're looking for the area bounded under the region. So it's like two equations. We have y equals 2x squared plus 10 as equation 1 and y equals 4x plus 16 as equation 2. This question falls under the application of integration. We know like area under the graph is like having a graph. Let's say we have a curve and a line. We need the area under the shaded portion, which is determined by the coordinates on the x-axis. This is point of intersection of the two graphs down on the x-axis to solve. And to find the point of intersection, we have to equate this equation to this. Both of them are y. We equate the y to the y to find the x coordinates. So we have 2x squared plus 10 equals 4x plus 16. We're equating the y for this to the y of this. Then we can say this equation 1 equals equation 2 without the y. That's we can say 2x squared plus 10x equals 4x plus 16. Since both of them separately equals y, so we have them, then we solve our algebra. 2x squared, we'll take the plus 4x inside, comes minus 4x plus 10 minus 16 equals 0. We have 2x squared minus 4x plus 10 minus 16 will give you minus 6 equals 0. We can factorize to simply get the x values, but we can also break this down since they all have 2 in common to make it easy for us to solve. We take 2 out, you'll be left with x squared. You divide 2 by minus 4, that's you'll be having minus 2x. Since they all have 2 in common, we can break it down to make it easy for us to factorize. Take out 2 divided by 2x squared, you'll be left with x squared. Minus 4x divided by 2 will give you 2x. Then 2 in 6 will give you 3 equals 0. You put it in bracket. You divide both sides by 2 to get rid of the 2. 2 in 0 is 0. So we have x squared minus 2x minus 3 equals 0. Now we'll factorize. We look for two numbers that will give you minus 3. When you multiply them, yet when we add them, we get plus 2. So we have 3 times 1 will give us 3. Since we have minus 2 when we add them, that means the bigger number should get the negative. So minus 3 and plus 1 are the two values. We replace minus 2x with minus 3 and plus 1. We can write any one first. We can have x squared plus x, that's 1x, minus 3x minus 3 equals 0. When we're factorizing, we're looking for a way to split this into 2. So we have this, you can now put them in separate brackets. What's common in these two? We have x in both of them. We take out x, we'll still be left of this x squared, you'll be left with x, and of this x you'll be left with 1 because x divided by x is 1. Then here, what's common? They both have 3 in common. We're not taking out just the 3, we are taking out with the minus. So we'll take out minus 3. Here we'll be left with minus 3x divided by minus 3. It's like saying minus 3x over minus 3. Minus cancels, minus 3 cancels 3. We'll be left with x. Then for the second part, we have minus 3 divided by minus 3. For the constant, we'll get minus cancels, minus turns to plus. 3 in 3, that's 1, equals 0. Since we have these two identicals, we know we're on the right part, so we'll take one of them, x plus 1, in bracket, then we'll take this x and this minus 3 and join them together. X minus 3 equals 0. X plus 1 equals 0, or x minus 3 equals 0. X equals minus 1, or x equals plus 3, because when you take out minus 3 it turns to plus 3, when you take out plus 1 it turns to minus 1. The minus 1 and 3 shows us the limit, that's the upper limit and the lower limit of the graph. So where they intersect at minus 1 and also at 3. So we have our 0 point here anyway. These are our graph 0 point. So these are the 2 points where they meet, and this is shaded part. So we use that and we integrate to get the area under the graph. With our limit minus 1 and 3, we can then integrate and get our area under the shaded region. With the limit, we can then find our area, which is a equals, you're differentiating with the limit 3 minus 1, then 4x plus 16 minus, that's for the linear graph first. Then the curved graph, that's the quadratic graph. We have 2x squared plus 10. We then differentiate that 4x, the x is raised to power 1, then 1 plus 1 over 1 plus 1 plus 16x. Since there's no value of x in front of 16, we know it's x raised to power 0 that will fit, plus 1 over 0 plus 1. We'll leave our big bracket 3 minus 1, our limit, minus. On the other side, we still have our open bracket. We have 2x to the power of 2 plus 1 over 2 plus 1 plus 10x to the power of 0 plus 1 over 0 plus 1. We'll close our bracket. We have 3 minus 1. Then we'll break it down. A equals 4x to the power of 2 over 2 plus 16x to the power of 1 over 1. Close our bracket. 3 minus 1. We have 2x to the power of 3 over 3 plus 10x over 1. We'll put our limits. We have a equals 2 here 1, 2 here 2, that's 2x squared plus 16x, that's 16 raised to the power 1. That's 16x over 1 is 16x. We'll close our brackets with our limits. Then we'll still have, you can't break this down, you have 2x to the power of 3 over 3 plus 10x. We'll put our limits. Then since they share the same limits, we can join them together. A equals, it's allowed in math, equals 2x squared plus 16x. Then this minus will change the sign of this and also this because it's in bracket when you open, as minus 2x cubed over 3 minus 10x. We close our bracket. They both share the same limits. We have a equals, we collect like terms, 2x squared plus 16x minus 10x minus, you join like terms, 2x cubed over 3, still sharing the same limits. We have a equals 2x squared plus 16 minus 10 is plus 6x minus 2x cubed over 3. We'll close our brackets. We'll put our limits. Since our limits represents the x coordinates, so we insert them and we use them in solving. Our area is therefore going to be, for the first part, that's 2, then you insert 3 squared plus 6, that's in 3, that's 6x, minus 2, then you have 3 to the power of 3 over 3 for the first part, minus, still the same thing using the minus 1 now. We have 2 minus 1 squared plus 6 minus 1 minus 2 minus 1 cubed over 3. Close bracket. We have inserted our x values, so we'll come on the next line and we'll open the bracket. We have 3 to the power of 2, that's 3 times 3, that's 2 times 9, close bracket, in bracket, plus 6 times 3, 18, minus 2, 3 times 3 times 3, that's 27 over 3, close our bracket, minus 1 times minus 1 will give us plus 1, that's minus 1 squared, that's plus 1 times 2 will give us 2, then we have plus 6 times minus 1 will give us minus 6, minus 2, minus 1 to the power of 3 is minus 1 times minus 1 minus times minus 1, which is us minus 1 over 3. You have to be careful with the signs. This is where Jamb makes it difficult. We have 2 times 9, that's 18 plus 18. Then 3 here 1, 3 here is 9. 9 times 2 is 18. Minus, in bracket 2, minus 6, minus 2 times minus 1 will give you plus 2 over 3. 18 plus 18 minus 18 will give you 18. That's like saying plus 18 minus 18 will give you 0. Then 0 plus 18 will give you 18 on this side minus. We'll find the LCM of what's on this side. LCM is 3. 3, that's like saying 2 over 1, 6 over 1, and we're solving with fractions. 3, we have 3 in 1, 3 times 2, that's 6. We have 3 in 1, 3 times 6, that's 18. 3 in 3, that's 1. 1 times 2, that's 2. 18 minus, we still have in our bracket, we have 6 minus 18 plus 2, that will give us minus 10 over 3. Then we have 18, the minus minus gives you plus 10 over 3, which gives you, if you find the LCM, that's 3, that's 18 over 1. 3 in 1, 3. 3 times 18, that's 54. Plus 3 in 3, 1. 1 times 10, 10. Our answer will be 64 over 3. Our answer is D. That's 64 over 3.